Hello everyone. Am I audible?
Yes, ma'am.
Yes, ma'am.
Yeah, so this is your week 5 session. So from week 5 to week 8, you will study about permutation combination. So in week 5 and 6, basically, we will study about permutation and combination. And then in week 7 and 8, we will study about the probability. Okay. So week 5 and 6 are very important for week 7 and 8 content. Okay. So I'm sharing my screen now. Is my screen visible?
Yes, ma'am, it is.
Okay. So first of all, have you all seen the videos? You have started watching?
No,
Yes,
ma'am.
ma'am.
Okay. Okay, no issues. We'll discuss the concepts first and we'll see some examples on those concepts. Okay. So the very first thing is addition rule of counting. Okay. So anyone who knows about what is the addition rule of counting?
Madam, today content is week 5, ma'am.
Yes, this is week 5.
Okay.
Okay, so addition rule of counting so says that if you have an action A, okay, that can be done in n1 different ways. Okay, you have something like an action A, okay, that can be done in n1 different ways. And then again, you have a different action, suppose B, that can be done in n2 different ways. Okay, so the number of occurrences for action A or B, okay, that is n1 plus n2. So if I take a very common example, so suppose you have 4 shirts, you have 4 shirts, suppose, and suppose you have 3 number of pants. Okay, and you have to select one thing out of these 4 shirts and 3 pants. So here you can suppose that this shirt is a action A and this pant is a action B, which means that selecting an object from shirt that you can consider as A, and selecting from pants that can you consider as action B. Okay. Now here in the addition rule, we are talking about A or B. Okay. So what are the total number of occurrences for A or B? So A or B, which means suppose you have to select one thing, like either a shirt or a pant. So in how many ways you can do that? Okay, so again, I'm repeating the question. You have 4 shirts in total and 3 pants. Okay, so in total you have suppose 4 plus 3 total number of objects. Okay, and from these 4 plus objects, you have to select one thing. Okay, it can be either a shirt or it can be either a pant. So in how many ways can you do that?
That would be 4 plus 3, 7 ways.
Yes. Okay. And if I ask you what is N1 here and what is N2 here for this particular example?
N1 is 4 and N2 is 3.
Yeah, correct. Okay. So now, if that makes sense, what is the meaning of this action A and action B? Okay. So there will be something, some object or some items you can say. Okay. So from these two different kind of things. Okay. So there will be something A or some B. So here it is given as shirt and pant. Okay. And we are talking about or condition. Okay. Which means either you will select a shirt or you will select a pant. Okay. So this kind of problems you can do with addition rule of counting. Okay, so now I will write its theory. So we can write that if an action A can occur in N1 different ways. Okay. And another action B can occur in N2 different ways. Okay. So then the total number of occurrences okay, of action A and B. Sorry, A or B. Okay, so that is N1 plus N2. Okay, so you need to remember this thing that there is a OR condition. So in that case, you have to add the number of possibilities for A and B. Okay, now the next one is multiplication rule of counting. Now in multiplication rule of counting, so again, suppose you have 4 shirts and 3 pants. Okay. Okay, now you have to select 1 shirt and 1 pant out of these. Then how can you do that?
4 into 3, 12 is.
It will be 4 into 3, right? So there can be 12 possible combination in which you can select 1 shirt and 1 pant, right? So here you can see that there is not OR condition, there is a AND condition. Okay, because we are selecting both shirt and pant. Okay, previously we were selecting only one thing out of these two. Okay, and here we were selecting both the things. So here I can write that if an action A can occur in N1 different ways, and another action B can occur in N2 different ways, okay, so then the total number of occurrences okay of action A and B. Okay, A and B together. So this will be N1 into N2. Okay, so here is a AND condition. So then you have to multiply. Okay, now let's see an example on this. So suppose you have to create a 6-digit alphanumeric password. Create a 6-digit alphanumeric password. Okay. And there is the condition for making the password is that password, okay, it should have first 2 letters, okay, followed by 4 numbers. Okay, now tell me, how can we do that? Okay.
Letters
From
were
all the
kept
alphabets, select
small.
two alphabets and then multiply it by all the numbers. Select four numbers from all the possible numbers.
Okay. So,
Alphabets are
see,
capital or small?
yeah. So in this particular question, no condition is given. So we will take only one case. Okay. Like we will take only uppercase or lowercase, not both. And one thing that there can be two conditions. Okay. Like we have to repeat the elements or not. So if we are taking that, repetition is allowed. Okay, we will see in both the condition how can we do this question. Okay, so first of all, we have 6 places to fill. Okay, so in the first 2 places, we have to fill alphabets. And in the other 4 places, we have to fill the numbers. Right? So if suppose repetition is allowed, then in how many ways we can do that? So for the first place, how many possibilities?
26
26
multiplied by
into
26.
2 into
Yeah.
26, yeah.
26 into 26.
26, 26.
Yes, ma'am.
Okay. For both the places, we can have 26 number of options. Now for the remaining places where we have to
Na-
fill the digits.
9 multiplied by, sorry, 10.
10.
10.
10
10
4.
multiplied by 10 multiplied by 4.
Yes, so it will be 10 into 10 into 10 into 10, 4 times. Okay, because we have 4 places to fill. Okay, now you can multiply, you will get the answer. So there can be another condition when the repetition is not allowed, right? Then how will you do that?
And then it is 26 multiplied by
25.
25.
25.
Yeah, so it will be
And then
26
10,
into
9,
25.
8,
8, 7.
7.
Into 10 factorial.
10 into 9 into 8 into 7.
10
Yeah,
factorial. No, factorial.
you cannot write factorial, because if you're writing factorial, then it will go up to 1. Okay, 7 into 6 into 5 into 4 3 1. Okay, so here you can see that you have 2 places for letters, for alphabets. Okay, so first can have 26 number of possibilities. Okay, and then for the second position we can have 25 number of possibilities, because one letter we have already filled at the first place. Okay, and similarly we can do for the numbers. Okay.
Can we do like 26C2 into 2 factorial ways for the alphabets, and for the numbers 10C4 into 4 factorial ways?
Yes, yes.
Excuse me, ma'am.
Hmm.
So if it is case sensitive, then how we will do that?
So then you will take, like, so then there will be 26 plus 26 number of possibilities for the first place. Okay.
Okay, ma'am. Okay.
So if it is mentioned, then only you have to consider that. Okay. It will be mentioned in the question if they are giving that condition.
Okay, ma'am.
Okay. Now let's see another example of the same kind. So suppose there are 8 athletes. Okay. Who take part in a race. Okay. So what are the possible number of ways that athletes can finish the race? Okay. And here we are assuming that there should be no time. So now how can we do this question? So we have 8 athletes, so which means we can say that we have 8 positions to fill. Okay. So how will we do that? For the first
8
place,
into 7
how
into
many?
6.
8
Yeah, how many
factorial.
possibilities?
8 into 8 factorial.
So
8.
for the first place, we have 8 possibilities, right? Then for the
7.
second place, we can have 7 number of possibilities, right? Because it is
Okay.
understood here that we cannot repeat the elements, okay? Because the person who got the first position will not be at the second position, right? So it is understood that the elements, or we can say the athletes, are not repeating themselves, okay? So it will be 8 into 7 into 6 into 5,
Factorial.
okay? Like this. Yeah, this is extra. Okay. Okay, so is this question clear to everyone?
Yes,
Yes,
ma'am.
Yes,
Okay,
yes.
so here you can see the use of multiplication rule of counting. Okay, next is factorial. So what is the meaning of factorial? What we do in that? Anyone?
Ma'am, we multiply that number and then go on n minus 1 in, let's say n factorial. So n into n minus 1 into n minus 2 into n minus 3 dot dot dot. That is the meaning of factorial.
Yeah, so we can say that it is the product of first n positive integers, right?
Yes.
So I can write that the product of first n positive integers. Okay, or we can say counting numbers, both are same. Okay, so this is called n factorial. And it is denoted as n factorial, like this. Okay, so n factorial is equals to n into n minus 1, okay, into n minus 2, and it goes up to 1. Okay, so now you can see that 1, 2, 3, 4 up to n. Okay, so this is the product of first n positive integers. Okay, now there are some remarks for factorial. Okay, we will see the questions also later. So the first one is that the value of 0 factorial is equal to 1. Okay, and we can write n factorial equals to n into n minus 1 factorial, right? Is that correct?
Yes.
Yes, ma'am.
Okay, suppose we
Yes,
have
ma'am.
5 factorial, so that we can write as 5 into 4 into 3 into 2 into 1. Okay, now you can see that 4 into 3 into 2 into 1. This is what? This is equal to 4 factorial. Okay, and you can also write it like this, that 5 into 4 into 3 factorial. Okay, that is also correct. So if I generalize this thing, so
Ma'am,
what can I write? Yes,
remark. 1 is 0 factorial. What is 0 factorial? Remark.
yes, what?
0 factorial equals 1 button. What is
The value of 0 factorial is equal to 1.
okay. 0 factorial is 1. Number of factorial is 2.
Your voice is not very clear to me actually.
It's 8.
Can someone listen to him properly?
No, ma'am, it's not clear.
Yeah. Okay. 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 So if suppose I is less than or equal to n, okay, then what can I write? So n factorial is equals to what? N into n minus 1, and it goes up to n minus I plus 1 into n minus I factorial. Okay, so you can see here that this value of I should be less than or equal to n. Okay, now you can relate this thing with this example. Okay, so 5 factorial, you can write it as 5 into 4 into 3 factorial. Okay, so here you can see that this 3 factorial is equal to 5 minus 2 factorial, right? So this you can write like this. So these things actually will help you in solving the problems or solving the in the calculation part. Okay, so you should know these calculative things.
Ma'am, this n minus I plus 1 is basically n minus I minus 1. I mean, inside the bracket I minus 1. Is
Yes,
that?
you can write like this. Okay, these two are same.
Okay. Okay.
Yeah.
What is
Okay,
this
now
I
On the
suppose,
plus?
third point, can you repeat? I'm not getting. Or you give
sorry,
us some examples. This I less than n. I'm not clear on this. You can give some examples
I
with
less than
numbers.
n.
Yeah, I'm not
Yeah,
clear
yeah,
on
okay.
this.
Okay, we'll take this example only. You can see that 5 factorial, you can write it as 5 factorial, oh, sorry, 5. Okay, then 5 minus 1, okay, into 5 minus 2, then 5 minus 3. Okay, so if I write, then this is 5, this is 4, this is 3, this is 2, and then it will be factorial sign here. Okay, so now you can see that what is the value of n and what is the value of I here for this particular example. Let's
N is
relate
5, I
this.
is 3.
Yeah, so here you can see that n is 5. Okay, so at the place of n and factorial, I have written 5 factorial. Okay, and then in the general formula, I wrote that it is going up to n minus I factorial. Okay, and this is what? N minus I plus 1, or you can write n minus I minus 1. Okay, so you can see in this particular example, I have written that the value of I is 3. Okay, so 3 will always be less than 5, right?
So this I value, they will specify, or any
That
value we can.
you cannot write that 5 minus 6 factorial. Okay, because maximum it goes up to 1, so it can be n minus n minus 1 factorial. Okay, see,
I can take a value between 1 and 5. That's what it means because
yes,
the n is 5, so I can
because
take
yeah,
1
so
to 5.
here it is a product of positive integers only. Okay, so you cannot take negative values. If I becomes greater than n, then the value will be negative. Okay, so that I can be less than or equal to n.
Okay.
Okay,
I can be 0, ma'am.
I can be 0. Yeah, so that will be the same value. Like you can write it as 5 minus 0 also. Okay, that will be 5. That is also possible.
Got it, ma'am.
Okay.
Okay.
So now suppose now you have to write this 25 into 24 into 23. Okay, you have to write it in terms of factorial. Okay, so how can we write this thing? So we have 25 into 24 into 23, and we want to convert it, or you can say we want to write it in the form of factorial. So what can we do?
Ma'am, we can multiply 22 into 21 up to 1 and divide
22
that.
factorial divided by 22
So
factorial.
Yeah. So if you
Yes, ma'am.
multiply with 22 into 21 into 20 up to 1. Okay. So then
Yes,
in the
ma'am.
numerator,
25
yeah, so
factorial
then,
divided by 22 factorial.
yeah, okay. So we have to multiply with this thing. Okay. Then in the numerator part, it will become 25 factorial. Okay. And since you are multiplying it, so you will have to divide also to make it, to balance this equation, right? So you will divide this, divide with the same value. Okay. Now in the denominator, what can we write? This will be 22 factorial, right?
22
22
I.
factorial.
22 I.
Right.
Correct.
Yeah, so it will be 22 factorial. So
That
now
should
you
be
can see that the both things are equal. Okay, 25 into 24 into 23. Okay, and we have written it into by using factorial, right? So the value of both are same. Okay, these are just used to express the same value. Okay, don't worry, like these are the basic calculation that you will be using in solving the problems. Okay, you will not get these questions like the same question in the exam. Okay, this is the very basic thing. These things are just to make you clear with these concepts. Okay, that how you can use these things in your questions. Okay, next thing is permutation. Okay, so permutation we will study in this week, and combination will come in week 6. So what is the meaning of permutation? When do we use that? Anyone?
Arrangements of items for a particular element.
Select and arrange.
Select and arrange.
Yeah, select and arrange. So suppose you have n number of items and you want to select some of the items or maybe all the items, and you want to arrange them. Okay, so arrangement is very important for permutation. If you have to arrange a particular number of items, then we will use permutation. Okay, so a permutation is
Ma'am, in permutation, order
an
matter or
ordered,
not?
yes, order matters. Order matter, which means that you are arranging something. Okay, in arrangement only the order will matter, right? So arrangement matters here,
Okay.
order matters here. Okay, so permutation is an ordered arrangement of all, or you can write some. Okay, maybe all the items you are selecting, or maybe you are selecting some of the items. Okay. Now we will write the formula, the basic formula for permutation. So the number of possible permutations okay, permutations of R objects from a collection of n distinct objects. Okay, so that is given by. So we denote it like this, n p r. Okay, which means out of the total n number of items, you are selecting r items and you are arranging them. Okay, so the formula is n factorial divided by n minus r factorial. Okay, so this is the formula where all the n objects are distinct. Okay, we will later see the case where the items are not distinct. Okay, where the items are identical to each other. So we will see that case also. But if you have all the n items which are distinct and you are selecting r objects or r items and you have to arrange them, then you will use this formula. Okay, NPR, which is equal to n factorial divided by n minus r factorial. Okay, now let's see an example of it. So suppose you have 3 objects or 3 items or whatever you want to say. Suppose you have 3 things A, B, C. So I can write that the value of n is equal to 3, right? Is this clear? We have total n number of objects, which is 3 here. Now, the first case I will take that I am selecting all the 3 outcomes, sorry, 3 items, and I want to arrange that. Okay, so take all at a time. So I can write that n is equals to 3 and r is also 3 here because we are taking all the n outcomes. So both n and r are same. If I arrange these 3 items, I can write that I can arrange it like this A, B, C or A, C, B, right? Or I can arrange B, A, C or maybe B, C, A, or it can be C, A, B or C, B, A. Can you think of any other possibilities apart from this for arranging these 3 letters? No, right?
No,
So we
ma'am.
can
Yes.
see that we have 6 number of possibilities to arrange these 3 letters, right? So here we have arranged it without using any formula or anything. Like in general, we will arrange it like this. Okay. So for a small number of items, you can see, you can arrange, you can write it like this, but you have a very large number of items, then we can use the formula. Okay. So if you want to verify the formula, so we have seen this example. Okay. So we have arranged it and we saw that there can be 6 possibilities. Now we will see that whether the formula gives you the same value or not. Okay. So NPR here we have 3P3. Correct? We have the value of n as 3 and the value of r also as 3. Now, according to the formula, I can write this as 3 factorial divided by 3 minus 3 factorial. So this will be 3 factorial divided by 0 factorial. Okay. So 3 factorial I can write as 3 into 2 into 1, which is equal to 6. Okay. Is this clear to everyone?
Yes, ma'am.
Yes, ma'am.
Okay, so now we can see that from the formula also we got the same value. Okay. Now there can be another case. Suppose I'm not taking all the n letters, all the 3 letters here. Suppose I'm taking 2 letters at a time. Okay, so in total I have A, B, C, 3 number of letters. Okay, I have n is equals to 3. Now I am taking only 2. Okay, which means out of the 3 letters, I am selecting 2 letters and then I have to arrange them. So the value of r will be 2. Is that correct?
Yes,
Yes,
ma'am.
no?
It is
Yes,
correct.
ma'am.
We are arranging two now.
Yes, yes. So we have to select 2 items or 2 letters and then we have to arrange them. Okay, so now suppose I am selecting A, comma B. So how can I arrange? So it can either be A, B or it can be B, A.
The
Okay,
2
only 2
factorial ways.
yeah, 2 ways are there for this thing. Or maybe out of A, B, C, I am selecting A, comma C. And then I have to arrange it. So it can be A, C or maybe C, A. Okay. Now, out of ABC, I am selecting B, comma C. So then this can be arranged like this, B, C, and then C, B. Again, we can see that we have 6 number of possibilities. Okay, now we will see from the formula. So from the formula, it should be 3P2, right?
Yes, ma'am.
Okay, so it will be 3 factorial divided by 3 minus 2 factorial, which is 3 factorial divided by 1 factorial. Okay, so this will again be 3 into 2 into 1, which is again 6. Okay. So in this way, you can use this permutation formula for selecting your items and arranging them. Okay, is this clear to everyone?
Yes, ma'am.
Ma'am, this works in a way that you have three ways of selecting the two objects and then arranging each of the selection in two ways. So 3 into 2. Is that the right logic?
Sorry, can you please repeat?
The way this works is AB, AC, and BC are three ways of selecting two objects out of three, and then each
Yes.
selection has two arrangements. So 3
Yeah,
into 2.
that is fine. Yeah, it's correct.
Okay.
Okay. So in permutation also, so later you will see the relation between permutation and combination. Okay. So there you will see that permutation is actually equal to selection and arrangement. Okay.
Ma'am, here you are selecting 2 out of 3 and then arranging, right?
Yes, yes.
Okay.
Okay. So you can see that first we have selected 2 items, right? You can
Yes.
see. And then we have arranged it.
Yes.
Okay.
Yes.
Okay. Yeah. Yeah, just give me a minute. Yeah. Now we'll see some cases for permutation. Okay. So what is the value of NP0? So NP0 according to the formula, it will be n factorial divided by n minus 0 factorial. Okay. So n factorial divided by n factorial, this is equal to 1. Okay. Then suppose, then we have NP1. Okay. So NP1 will be n factorial divided by n minus 1 factorial. Okay. Now we will solve it. Yeah. So n factorial we can write as n into n minus 1 factorial. And in the denominator also we have n minus 1 factorial. So this will be equal to n. Okay. So from this NP1, you can see that if you have n number of objects and you have to select only one object and you have to arrange it. Okay. So that can be done in n ways. And since you have only one item, like you are selecting only one item here, right? So arrangement actually doesn't have any meaning, right? Okay. So here I can write that there are n ways of choosing one object out of n. Okay. Similarly, we can see the value of npn. Okay. So npn will be n factorial divided by n minus n factorial. Okay. Which is n factorial divided by 0 factorial, which is n factorial. Okay. Now, if you convert this thing, okay, I mean, if you interpret this thing, npn, so what are we doing here? We have n number of objects, right? And we are selecting all the n objects, and then we have to arrange them. Okay. So that can be done in n factorial ways. Okay. Or you can also write that we can arrange n distinct objects in n factorial ways. Okay. If you have to arrange n items, that you can do it in n factorial ways. Okay, is this clear to everyone? Now let's see it.
Yes, ma'am.
Then
It's
it
clear.
will be clear. Okay, we'll see the application of it. So suppose from a committee of 8 members or 8%, okay. So in how many ways can we choose a chairman and a vice chairman? Okay, and we are assuming that one person could not hold more than one position.
Ma'am, this means repetition is not allowed. Is that
Yes.
okay?
Okay,
In
so
committee,
this is your
how many
question.
person, ma'am?
Sorry.
From the committee of how many person? 8 or
See, you have 8% in a committee and you have to select 2 members for chairman
okay.
position and vice chairman position. Okay. And it is given that one person cannot hold more than one position. Okay. So now you have to interpret this thing that you cannot repeat the elements here. Okay. So these things that repetition is allowed and repetition is not allowed, this will not always be given to you directly. You have to understand the question and check whether repetition is allowed or not. So here you can see that you are selecting a person for 2 different positions. Okay. And it is already given in the question that one person cannot hold more than one position. Okay. Which means that repetition is not allowed. Okay. Now you can see. So how will you solve this question? You have
8
to
P2.
put, yeah. So you can think of this question in 2 ways. Okay. So it can be 8P2, or you can solve it like this, that for the first position, we have 8 options, 8 choices. And for the second position, we have 7 options. Okay. So both will give you the same answer. Okay. So from this formula of permutation, so it will be 8 factorial divided by 8 minus 2 factorial. Okay. So it is 8 factorial divided by 6 factorial. You can solve it and you will get the same answer. Okay. We can write it like this, 8 into 7 into 6 factorial. And this is 6 factorial. So this will be 8 into 7, which is 56. Okay. Is this question clear to everyone?
Yes, ma'am.
Yes, ma'am.
Yes.
Yes, ma'am.
Okay. Now let's see
Ma'am, here
Hmm.
this and is given. That's why we are multiplying, right? And
Yes.
if instead of and if there was or, then like would it be 8 plus 7 or 8 plus 8?
See, then the forming of the question will be different. Okay. So
Okay.
yeah, because here you can see that you have to select for 2 different positions. Okay. So you have to select
Yes,
for
ma'am.
both, and you cannot repeat the elements. So it is 8 into 7. If suppose repetition is allowed, okay. If it is written that
Yes,
one
ma'am.
person can hold more than one position, then it will be 8 into 8.
Yeah.
Okay.
Ma'am,
Ma'am,
8
this
plus 8, right?
question, ma'am, this
No.
question, can we write 8C1 into 7C1?
Yes, you can write. Okay. So
Okay.
8C1, which means for the first position, you are selecting 1 out of the 8. And
Yes.
then for second position, you are left with only 8 members. Then so out of the 7, you are selecting 1. Okay. So that is also fine.
Yes. Okay.
Yeah. Since we have not studied the combination thing here, that's why I'm not using those things. Okay. We will see week 6, and then those things will be more clear. Okay. In week 5, we will focus more on permutation formulas. Okay.
Okay.
Yeah, that is also correct.
Okay.
Yeah. Okay, so next we have create a 4-digit number using the digits 1, 2, 3, 4, 5. Okay, and the condition is no digit is repeated. Okay, so this is the question. So in this question, you are given these elements. You can see you are given 1, 2, 3, 4, 5. These numbers are given to you, and you have to create a 4-digit number. And repetition is not allowed. Okay, no digit is repeated. So how can you do?
5p4. 5 fact.
You can do 5p4. Okay, so you can see that you have n is equals to 5 here. Okay, you have n equals to 5 number of objects. Out of those, you have to select 4 items, right? Because it is given that you have to create a 4-digit number. So ultimately, you have to select 4 numbers out of these 5 numbers, and you are creating a password, so you can arrange it also, right? Arrangement will matter here. Yes or no?
Yes, ma'am. It will matter.
Yeah, so it will be 5p4. So 5 factorial divided by 5 minus 4 factorial, which is 5 factorial. This will be 120.
120. Yes.
Ma'am,
Okay. Yes.
ma'am, if the repetition of digit is allowed, then the arrangement is doesn't matter, no?
Okay. Yeah, 1 minute. Okay. See, you have 4 places to fill. Okay. So first I'm taking the non-repetition case. Okay. So you can again solve this question like this, that repetition is not allowed. So it will be 5
5
into 4 into
into 3 into 2.
3 into 2. Suppose if repetition is allowed, then it will be 5 into 5 into 5 into 5. Okay.
Okay.
We will see this formula also. I will write it. I will write the theory of this concept.
Ma'am, I am asking about the arrangement, not this, ma'am. Ma'am,
So
if the
that will matter.
repetition,
That will also matter. Arrangement will matter there.
ma'am, if the repetition of digit is allowed,
Yeah, it will matter. Because suppose you are writing 1, 2, I'm creating a password, suppose 1, 2, 2, 3. Okay, or you can write 3, 2, 2, 1. Okay, so these two are different. You are repeating the your items, but these two passwords are different, right?
yes, ma'am.
Okay, yeah.
Ma'am,
Hmm.
how to get 120?
Sorry?
How to get 120? 5 factorial equal to 120.
Yeah, if you multiply it 5 into 4 into 3 into 2, then it will give you the value 120. Okay, now next is, in this question only, you have to find that how many ways you can make a even number password. Okay, so how many of these will be even? Okay, so it is a part of this question only. So in the first case, you have seen that we have created a 4-digit number where repetition is not allowed. Now in the second case, you have to see that how many number of ways can be there where this number will be an even number. Okay, so how many things you have? You have n equals to 5 here again. Okay, and again you are selecting, you have to select 4 digits. Okay, you have to create a password, but the condition is that the number should be an even number. Okay, and repetition of digit is again not allowed. Okay, Now just think of that, how can you do that? You have these numbers 1, 2, 3, 4, and 5. And you have to make a
Ma'am, we
four-digit number which
can
should be even.
fix the rightmost digit, and that we can do in 2 ways.
Hmm.
And the rest part we can do 4p 3 ways. Is that?
Yes, correct. So
Okay.
yeah, so we have to make a 4-digit password, right? We are given the digits 1, 2, 3, 4, 5. Okay, so to make the number even, the number should end with either 2 or 4, right? Then only the number will be an even number. Okay, is that correct?
Yes, ma'am.
Okay, so there can be a case where the number is ending with 2. Okay, and there can be another case where the number will be ending with this number 4. Okay, so now we'll see the number of possibilities. So for the last position, we have fixed this number. So there is only one way to fill this position, right? Okay.
Yes, ma'am.
I will use a different color so that you don't get confused. It is not 1 by 2, okay? Don't consider as 1 by 2. Okay, so here we can fill with only one choice. Only one choice is there, okay? Because we are fixing 2 here. Now we are left with 3 different positions to fill. So you can see that out of 1, 3, 4, and 5, we have to select the number, right? Because already 2 is fixed here and repetition is not allowed. Okay, so we are left with these 4 digits, these 4 numbers, and we have to fill these 3 positions. So we can write that it will be 4, 3, and 2.
4 is already repeated, right? 4 also removed, right?
Okay, again you are getting confused. See, here I am writing the number of possibilities. Okay, not the number.
Oh, okay, sorry.
Okay. So you can see that this 4 is like 4 options are there to fill the first position. 3 options are there to fill the second position. Then 2 options are there to fill the third position. Okay, these are not the like numbers from there. Okay, that's why I have written it from with a different color. Okay, now suppose you are taking another case where you are ending the number with 4. So then you are left with 1, 2, 3, and 5, right? Is that correct? Okay.
Yes, ma'am.
So
Yes, ma'am.
at the last position, you have filled this number 4. So we have only one choice. And for the other position, it will be 4 into 3 into 2 like this. Is this making sense? Okay.
Yes, ma'am.
Now you can use the formula also for this. So you can see what are we doing here. Out of the 4, we are selecting 3 numbers, right? So it can be done in 4p 3 ways, right? That will be 24. If you multiply 4 into 3 into 2, that will also be 24. Here also, what are we doing? Out of these 4 numbers, we are selecting the 3 numbers. That can be do 4p 3 ways, which is 24. Is this correct? Is this clear to everyone?
Yes, ma'am.
Okay, I'm just telling you that you can think of like this also, that 4 into 3 into 2, or you can directly use the formula. Okay, both are correct and both will give you the same answer. Okay, now how many total number of ways will be there to make a
48.
even
24
password?
plus 24.
Plus
Yeah.
2 we have to add,
So,
right?
so total will be 24 plus 24. So which is 48. Okay, now is this question clear to everyone? Okay, so in the first question, we were just creating a 4-digit number password where repetition was not allowed. In the second, again, we are creating a 4-digit number password with no repetition allowed, but the number should be a even number. Okay, so number is a even number, so which means that the number can end only with 2 or 4. Okay, so again, we are restricting it. So we have one more condition according to which we have to solve this question. Okay, so for that we have fixed this number, the last position, we have fixed it.
Ma'am, this two digit we are excluded, right? Right now, out of 4, 3 only we have taken. So we have to add a 2, right? This 2 and 4
See,
possibilities.
we are no, we will not add anything. See what, so you can see that 2 is not written because 2 has already come at this position. I have written here this 2.
Okay.
Okay, and repetition is not allowed. So which means out of the remaining digits, which is 1, 3, 4, 5, from that you have to fill for these 3 positions. Okay, we have not excluded it. It already has come at the last position. Okay, for the last for the second part, you can see that 4 has already come at the last place. Okay, and repetition is not allowed. So we have to select the numbers from 1, 2, 3, 5 for the remaining these 3 positions. Okay.
Ma'am, there are a total 72 possible number of password with odd password.
For odd also you can do. So for odd you will take these 3 cases, 1, 3 and 5, and you can see.
Yes, ma'am.
Yeah. Anyone else having any doubt? Otherwise I will see the next thing.
Yes, ma'am, it is clear.
Okay. So there are few more formulas of permutation where you will see that if the objects are not distinct. Okay. So then in that case, how can we arrange and select? Okay. So the number of possible permutations of our objects from a collection of n distinct objects when repetition is allowed. So this is given by the formula. Okay. So that we can do n into n into n up to n r times. Okay. So that we have already seen this thing. Okay. So we have seen this thing where we were doing it like that 5 into 5 into 5. Suppose in this question only, suppose if the repetition of the digit is allowed, then it will be 5 into 5 into 5 into 5, right? So you can see that you have to select 4 items. Okay. So that will become 5 to the power 4, okay, which is n to the power r, right? So in total, we have 5 numbers, okay? And you have to take 4 out of those 5, and repetition is allowed. Okay, so that will become 5 into power 5 to the power 4. Okay, if you see in general terms, so that will be n to the power r. Okay, this is the formula I have written.
Okay, ma'am.
Okay, so this is the same thing.
And how we can differentiate which formula, which formula we have to use?
Yeah, so that's what you have to see. So you have to use this formula when repetition is allowed. Okay, so those things, it can be directly mentioned in the question, or it can be, you have to interpret from the given statement. So that you have to understand by the given question. So in that question, it was already written that repetition is not allowed. Okay. And in that question, in this one, where you have to select the vice chairman and chairman. So it is understood that that repetition is not allowed. Okay. So that you have to understand from the question itself. Okay. And then accordingly, you can decide which formula to use. Okay, you try solving the questions of activity practice assignment, then you will be able to understand. Okay, now there is one more thing. When objects are not distinct. Okay, in that case, how will you arrange? So, the number of permutations of n objects when p of them are of one kind and rest are distinct. Okay, so this is equal to, so this is the formula, n factorial divided by p factorial. Okay, so if you if you want to see example, you have a word data. Okay, and you want to arrange the letters of this word. So here you can see that we have, in total we can see we have 4 letters, but you can see 2 letters are same. Okay, that is what it is written, that p of them are of one kind. So here 2 items are of one kind. Now tell me, according to this formula, how can we arrange the letters of this word data? So here the value of n will be what?
4.
4. And value of p will be
2.
2. Okay. So the answer will be 4 factorial divided by 2 factorial. Okay. So this is one case where only like these 2 letters are same. Sorry.
Ma'am, repetition is allowed here in this example.
One
Am I
minute.
audible, ma'am?
Yes, yes, you're audible.
Okay.
Ma'am, suppose we have P also 2 letters in some different case, and then how will solve?
Yeah, there is one more case. Suppose, so in this particular question, you can see only one letter A is repeating itself. Okay. So there might be another case where more than 2, like suppose T is also repeating. Then how will you do that? Okay. So I'm going to write that formula. Okay. So the number of permutation of n objects.
What is P, ma'am?
1 minute, I'll explain. If P1 is of one kind, okay, and P2 is of second kind, okay, and so on, Pk is of kth kind. Okay, so this is given by, then what you have to do, you have n number of items in total, Okay, so which is n factorial. Okay, and then you have to divide by p1 factorial into p2 factorial up to pk factorial. Okay, so now let's take an example for it. You have a word statistics. Okay, now here you can see that the letter S is coming 1, 2, 3 times, right? Then letter T, it is coming 3 times. And then letter A is not repeating. Letter I is coming 2 times. Is that correct?
Yes, ma'am.
Okay. So now according to the formula, N is what? Count the total number of items. It is 10. The value of N here is 10. Okay, you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in total you have 10 number of letters, 10 number of items. So which is 10 factorial. Now you can see that some of the items are not distinct. Okay, not every letter is unique. T is repeating. Okay, then I is also repeating itself. And then this S is also repeating. Okay, so you have to divide with that many number of times. So you can see that S is repeating 3 times. So you have to divide by 3 factorial. Okay, then T is repeating 3 times. So again, you have to like this is multiply and divide 3 factorial. Okay, and then I is repeating 2 times. So you have to multiply here 2 factorial. Okay, now is this clear?
Yes, ma'am, it is
Now
clear.
go back to the formula again, that P1 is of one kind. So P1, which means that 3 of the letters are of same kind. Okay, they all the 3 are same. Okay, so this is, you can say P1. Then P2 is of second kind. Okay, so you can see that this S. Okay, S is suppose P2. So these 2 number of letters are of same kind. Then we have PK or P3. So here we have 3 items which are of same kind. So I is the letter which is again of same kind. Okay, it is coming 2 times. The same letter is coming 2 times. So you have to divide by 2. Okay, so you have to see that which of the items or letters are repeating themselves. And you have to divide with the number that how many times they are repeating themselves. Okay, so actually both the formulas, this one and these two are same actually. So in the first case, only one item was there which was of same kind, like which was repeating itself. Okay, so you can see that here only letter A was repeating. And in the next question or the next formula, more than one items are there which are repeating themselves. Okay, so both are actually the same thing. You just have to like
Ma'am, in
understand by the given question.
Ma'am, in that data
So
case,
from the question, you have to understand. Yes.
Can I ask, ma'am, now?
Yes.
Ma'am, I'm asking that in this case, if we are allowing the repetition, then it will be 3 to the power 4, right? Sorry, 4
Why
to
3
the
to the
power 3, right, ma'am? No, 3 to the power 4, I guess. So we want to make a like a letter where 4 alphabets are there. So in how many ways we can do this if repetition is allowed?
Okay, so you have these letters and you want to
Huh.
make a four letters.
Yes,
right?
ma'am. Then 3 into 3 into 3 into 3, right, ma'am?
If repetition is allowed, yeah, if you're asking the question in that way, that it will be 3. Okay, repetition is allowed, yeah, 3 into 3 into 3.
Yes, it would be 3 to the power 4, right, ma'am?
Yes.
Okay. And ma'am, like how this formula is derived, I mean, can we know the derivation of this? Like how we get this formula, this
So
identical
the thing
one?
is, see, the thing here is that you have four, if you have n number of objects that we can arrange in n factorial ways, right? Okay,
Yes, ma'am.
first of all, so here you can see that you have four letters. Just don't like you just see the number of items here. Don't think of like it is repeating itself. First of all, you have four things, okay, which you have to arrange. Okay, so that can be done
Okay,
in
ma'am.
4 factorial ways. Okay, so in numerator, we will take
Okay.
that concept. Okay, then you can see that this letter is actually repeating itself. Okay, so if
So
you
we are
see that,
considering this, those are distinct, right? Like we are considering for a while that this A letter is
uh,
distinct.
yeah, for the, for the numerator case, we are taking that these two are different things. Okay, if suppose it
Okay,
is
okay,
A1
okay.
and A2, okay, and now you see, so now you have four items that you have to arrange. Okay, so that we can do in 4 factorial ways. Okay, now the
Okay,
actual
ma'am.
thing is, okay, now actually these A1 and A2, these are actually same. Okay, for an instance, I have written A1 and A2, but these are actually same. Okay,
Okay, ma'am.
okay, so that if suppose this is A1, A2, if I write like this, if I write like this, okay, so if these two are actually distinct, then these two arrangements are different, but these two are same. Okay, okay, are you getting my point?
Okay.
That these two are actually same. So if you write this A here or here, both are same actually. Okay, there is no
Okay,
A1 or
okay.
A2, these are A only. So we have to actually remove that, remove
So
those.
we are, it has
That's
been
why we have,
reduced with 2 for now.
yeah, so that's why we have to, yeah, because it is repeating two times. Okay, so that's why we have
Okay.
to divide by 2 factorial. In this way, you will get only the unique arrangements.
Okay. So for
Okay.
second and third position, it has been like if we are placing this A on second and third position, it has been reduced by 2. And in that way, if we are considering for all like all selections, we can say, then that would be 2 factorial, right, ma'am?
This is
So
this 2 factorial is irrespective of the position. This only
that
means
is
that you have one letter which is like repeating 2 times.
Ma'am, if it was repeated
okay.
in 2 more times, then
If
if A
suppose,
is
okay,
repeated 2 more times.
if suppose, yeah, if suppose it is DATA. Okay, suppose it
No,
is,
ma'am. Only it is if data is repeated to
suppose this is
A.
some word. Okay, suppose this is some word. Okay. For an instance, just suppose this is some word and you have to arrange it. Arrange the letters of this word. Now, how many in total you have? 1, 2, 3, 4, and 5. Okay. So that we can do in 5 factorial ways. But actually, these A, which is occurring 3 times, are same. Okay. So we have to divide by 3 factorial.
Ma'am, my doubt is the answer will be 3 factorial at the last 3 into 3, 3 raised to power 5.
It will not be 3 raised to the power 5 for this case. We
Ma'am,
can check the
actually,
value
you
of
can't
it.
be expanding this formula. 5 factorial, what means of 5 factorial, I think.
Ma'am, my query is in the last case, if that was we are repeating A 2 times, then answer is coming 3 raised to power 4. Am I right?
You're asking a different question or in this particular question only?
Ma'am, similar. No, I'm asking when we have repeated A 2 times, then answer is coming 3 raised to power 4. Am I right or wrong?
Okay, so what word you are taking first of all? You are taking this word ADATA or you are taking this word?
Old word, DATA.
Okay, you are taking the word data. Okay. And then
Yes, in this scenario, answer is coming 3 raised to power 4. Am I right or wrong?
3 raised to power 4. But what is your exact question?
My
Like you are
question is,
arranging the letter.
first of all, I want to know, is the answer right or wrong?
See, that can be like, what is the exact question?
No,
That I can, then only I can
arrangement
tell.
means like for relating to like we have related 4 factorial to 2 factorial. So we are getting answer 3 raised to power 4. And the similar
Yes.
answer is coming 3 raised to power 4. So in the scenario of A data, will we be getting 3 raised to power 5 as an answer or not?
3 raised to the power 4 will not be the correct answer for this question actually.
The first question.
Yeah.
So somebody told na 3 into 3 into 3.
So that the
But that
question
is
will be,
repetition is allowed.
yeah, that question is the different thing. That's what I'm saying. What is something we want to calculate? Okay. You are asking a different question and that person asked a different question.
Okay, that person has
Okay.
confused.
Yeah. So he was asking something else. Okay. That's why I'm saying.
So,
The
ma'am,
main thing is that
in
what
this
is asked in the
numerator,
question. Okay.
in this
I'll,
numerator part, this 4
so,
factorial.
hmm.
So, can I
Yes,
ask,
yes.
ma'am? So this just because this A is been repeated 2 times, so it can itself be arranged in 2 factorial ways, right?
Yes, yes, yes.
So that's and that is
Yeah.
included in this 4 factorial part, this
Yes,
numerator
yes,
part,
correct. Yes.
and that's why it gets divided so that it will not be
Yeah.
double counted. Is that
Yes, yes. Yeah, correct.
okay? Okay,
Okay, ma'am,
okay,
can
ma'am.
we move on to next thing?
Yeah, sure. Are you clear with this, the second part?
Yes, ma'am.
Okay. Okay, so now the next concept is circular permutation.
Ma'am, one question. In statistics, the repetition is allowed or not allowed? What condition we are getting this, dividing this? Little
See here
confused.
the condition, repetition allowed and allowed. This is not the questions. The question is just you just have to see the arrangement of these letters. Okay. So suppose like
Here
here
it is
you
repeatedly
have
coming.
S.
Not S is coming 3 times.
Yes, yes. Yes. So S is coming 3 times. So you can take S 3 times. Okay.
Okay.
And you can take only 3 times, not 4 times.
Okay.
Okay. So the question is you are given all the letters. You are given this word actually. And you have to rearrange the letters. So you have to see how many rearrangements you can have with these letters. Okay. So you can see that A is coming only 1 time. Okay. So how many times you repeat, like whatever arrangements you take, A will come only 1 time. A will not repeat itself. Okay.
Yeah, correct.
Okay, this is the thing. And S is coming 3 times. So whatever arrangement you take, S may come 3 times. Okay. Their position will change. Okay, this is the question. So you have all these letters and you have to fit all these positions. You have 10 positions, right? You
Yeah,
have
correct.
these 10 positions. You have word as statistics. Okay, so you can write like this. Okay, or you can write okay. So in this way, you have to arrange the letters. Okay.
Okay, ma'am.
Now you can see that A is coming 1 time only. Okay. And this S occurred 3 times. So that can come 3 times. So in this way, you have to arrange the letter and see how many arrangements can be there. Okay. Now the question is the repeating thing that you can see this is S, S, and S. Okay.
Yeah.
So there
Yeah.
might be, if for an instance I write it S1, S2, and S3. Okay.
Yes.
So the arrangement can be T, A, and suppose here I am writing S2, this T, I, suppose S3, T, C, I, and S1. Okay. Now you can see that all the letters are at the same position in both these two cases.
Okay.
Now I
Okay.
just
Two
Okay.
cases.
Got it. Now I got it.
Okay.
ma'am,
Yeah.
Yeah.
ma'am,
So for that's
I
the reason you are
just
dividing
forget the
this
loop.
3, right?
Yeah. So this S1, S2, and S3, for an instance, I have written. Okay. But
Written.
they are
Okay.
actually same. They are actually same. So you can see that
Ma'am,
Okay. Okay.
there can be these two cases where only these three are changing itself. But actually that arrangements are same.
Same. Correct. Okay. That's the reason you are
And
dividing this
yeah, that's
by
why we
S2.
have to divide those number of
Okay.
arrangements.
Okay. Thank you, ma'am. Now I got it.
And ma'am, here if we want to make a word of 4 alphabets, like using this statistics, then like how can we do it?
We want to select 4 items.
Huh.
You want to make a 4-letter word, right?
Yes, ma'am. Yes, ma'am.
And the repetition is allowed.
Repetition is not allowed, but like the
Okay, so
identical
in
one
that,
we
okay, so
can
in that,
consider. So what I'm saying is, let's say consider the data DATA, and we want to make two like a word which is having 2 letters. So a can occur 2 times, but not this D and T.
okay. Okay, so in these kind of questions, you will have to make cases and see. Yeah.
Okay. So
These are different kind of questions. So
several
generally we
cases
take,
will be there. Okay, ma'am.
yeah,
Okay, ma'am. Got it.
yeah.
What circular?
The next is circular permutation. Okay, now is this thing clear? What we were doing
Yes.
in these questions? Yeah.
Yes.
Yes, ma'am. It is clear.
One for first question.
So the thing we were studying till now, what in that we were doing a linear arrangement. Okay. And in this one, we have to arrange the items according to a circle. Okay. So now suppose you have 4 letters A, B, C, and D. Okay. So if you see the linear arrangement, it will be like A, B, C, D, A, B, D, C, A, C, B, D. And in this way, you can arrange the letters linearly, right? Now we will see the circular thing. So suppose this is a circle according to which you have to arrange the 4 letters. So this one way can be this A, B, C, D like this. Okay. Now the same thing I can write. So here at this position I have written A. Okay. Now suppose in the next case I write A here and then again A, B, C, D. Okay. Next, suppose I write A here, then again I go with A, B, C, and D. Okay. Now next, suppose I write A here and then again I am going with A, B, C, and D. Okay. Now in the case of circular permutation, all these 4 are actually same.
Yes, ma'am.
Okay. Why they are same? You can see that next to A, B, and D are there. Okay. Or you can see that we are going in this in this way, like A, B, C, D. Okay. And then again go back to A. Here also you can see A, B, then C, then D. Okay. Here also A and then B, then C and then D. Like this. And here also. Okay. Or you can see that next to A, you have B and D. Here also you can see that next to A, we have B and D. In this arrangement also, and in this one also. Okay. So all these four kind of arrangements are actually same. So what are we doing? Actually, we are just rotating it. Okay. So since it is a circle, so there is no starting or ending point for a circle, right? That's why all these four arrangements are same. Is this thing clear to everyone?
Okay.
Yes, ma'am.
Okay. So these four are same. These four things are considered as same. Okay. Now we'll see that how can we arrange these four letters in a circular form, circular manner. Okay. So these four are same. Now let's see the different arrangements of it. Okay. So this is one case which we have already seen, that A, B, C, and D. Okay. Next can be again A here. Okay. One more thing, that in circular permutation, what we do actually is we just fix the position of one element. Okay. That element can be any of the elements, but what we have to do, we have to fix the position of one element, and then we arrange the remaining element like a linear fashion. Okay. So just see here that what I am doing here, I am fixing the position of A. Okay. So I will write A here all the time. Okay. Now I will rotate, I will like change the position of these three, B, C, and D. Okay. Now let's see how can we do that. Okay. So this is A. Then here I am writing C. This is D. And this is B. Okay. Next, I can write it that here A, then D, then B, and then C. Okay. Or we can write that this is A, this is B, this is D, and this is C. Okay. Next, this is A, this is C, B, and D. Okay. This is A, this is D, C, and B. Okay. Now there can there be any other possibility of it? Can
No,
you
ma'am.
think of it? No, right?
No,
And you
ma'am.
can see that all these six are different. Okay. If you're taking clockwise and anti-clockwise as different. Okay. Clockwise and anti-clockwise are different, which means you can see that here A, B, C, and D. Okay. Here you can see that if you go anti-clockwise, then you will get A, B, C, and D. Okay. So these two are actually the mirror image of each other.
Okay, okay.
Okay. Just look at these figures carefully. You can see that these two are mirror image of each other. These two are also mirror image of each other. And these two are also mirror image of each other. Just look at the figure and think about it.
Yes, ma'am. So what about the why we have fixed a variable?
Yeah, so this is, you can say that the method to arrange the letters. Okay. Arrange the items according to a circular manner. Okay. So you can fix A also, or you can take any other letter also. Maybe you can fix the position of B. Okay. And then also you can arrange. And again, you will get the same kind of arrangements. Okay. You can just do it on your own and see. So
Yes, ma'am.
just look
Okay.
at these figures and see all these are distinct. Okay. If you are taking the mirror image as different, like the clockwise and anti-clockwise are different. Okay. In mirror, what happens? Left becomes right and right becomes left. Is that correct? If you see a mirror image of something. This is the
But
only
ma'am,
change. So you can
C
see,
is flipping now. Ma'am, but C is flipping.
yeah, you can see the flipping things also. Okay, so here you can see that D is this side and here D is at the right side. Here B is at the right side, but B here in this figure is at the left side.
They are considered as distinct arrangements, right, ma'am?
Yeah, so there can be
Yes,
two
mirror
conditions.
image.
Okay, yeah. So
Okay.
this is the one thing, like if you're taking the mirror image or the clockwise and anti-clockwise are same or is different. Okay, so these two things are there. Okay, just keep
Each
that
type
thing
of
aside.
all arrangements are different, na? Six different
Yes.
arrangements.
Yeah, here we have 6 different arrangements. Okay, if you want to see, just look at these figures and see. Just check this thing. So in the first figure, you can see we have, like, next to A, we have B and D. In this figure, you can see we have B and C. Okay. In this figure, we have C and D. Okay. So all these 3 arrangements are different. Okay. Here also we can see that B and D are next to A and next to A, but the positions is getting changed, right? B was at the right side of it and D was at the left side of it. Okay, and here the position got flipped. Okay, but these are the only unique arrangements in circular fashion. Now, is this thing clear up to this point? Then I will move forward.
Excuse
Yes,
me.
ma'am, it is.
Hmm.
So,
Yes,
ma'am,
ma'am,
this
clear.
is like mirror image with respect to the fixed position, right?
Yes, yes. Fixed
Because
position.
like
See,
A is fixed, so it is a reflection around A, right?
Yes, yes.
Axis of symmetry. The
So that's,
vertical symmetry, I think.
yeah, that's what I'm saying. Like it here at present A is vertical, but it can be horizontal also. It actually is based on the position which is fixed. If I fix, say, for example, B, and then I can say that it
Okay,
is
okay. So suppose, okay, if I am taking this arrangement, then what will be the mirror image of it? It will be this.
A, C, D.
B, C, D, A.
Okay,
Right.
and we already have discussed that this arrangement is same as, right? After B, A should come, then after A, D should come, then after D, C should come. So you can arrange this one, like you can rotate this one and you can rotate this one also. Okay, so they both will be the mirror image, or you can say that clockwise and anti-clockwise are different.
Yeah, I think that like that is more clear because otherwise it gets a little confusing because it depends then
Yeah.
on which point we are starting.
Yes, yes. Okay. So that's why, like in the circle, there is no starting and ending point. That's why we take these kind of arrangement as same. Okay. These two are actually
Yeah,
same.
that's
These two are not different.
yes.
Okay.
Yes.
And this clockwise and anti-clockwise are same or not. So there are two conditions. Okay. So according to our scenario, we will decide that clockwise and anti-clockwise are same or not. Okay. So now these figures are clear to everyone.
Yes, ma'am. How question
Yes,
will
ma'am,
come?
it is.
Okay, I will write the formula and then we'll see. So there are two things. So the number of ways and distinct objects can be arranged in a circle. Okay, when clockwise and anti-clockwise are different. Okay, so clockwise and anti-clockwise are different. So this formula becomes equal to, okay, I will ask you to you. So what are we doing here? I said that we have n number of objects. So what we do, we fix the position of one element, and the remaining elements are arranged according to a linear fashion. Okay, so just think about it and tell me what can be the formula when
N
this
minus
minus 1 factor.
n minus 1 factorial. Okay, because if you have n number of objects, so that we can arrange in n factorial base. Okay, so here we have removed one object, or you can say we have fixed the position of one. So now we are left with n minus 1 number of objects that we have to arrange in linear fashion. So that we can do in n minus 1 factorial base. Okay, now in the cases when we are taking clockwise and anti-clockwise are same. If clockwise and anti-clockwise are same, okay, then the formula will be half of the previous one. Okay, so it will become n minus 1 factorial divided by 2. Okay, so you can see that we have in total we have 6 arrangement. Okay, but these two, and these two are mirror image of each other, right? So the total number, if clockwise and anti-clockwise are same, that will be half of when clockwise and anti-clockwise are different. Okay, is that clear? So you can see in total we had 6 when clockwise and anti-clockwise were different, and if both are same, then it will become 3.
Oh.
Okay. Okay, clockwise and
Okay, ma'am.
anti-clockwise are same. So there are a few examples for it. Suppose you are making a bracelet or a necklace of beads. Okay, in this kind. Okay, so in this case, you can see that if you flip it, again this bracelet will be the same. It will not be changing, right? So here the clockwise and anti-clockwise thing does not matter. Okay, so in these kind of scenarios, we take that clockwise and anti-clockwise are same. But suppose if you have a circular table where actually people are sitting. Suppose here person number A is sitting, here person number 2, 3 and 4 are sitting. In that case, if you flip the position of these two, okay, then it becomes a different arrangement. Okay, so here clockwise and anti-clockwise matters, but in this kind of scenario where you can actually flip, in the people sitting on the chairs, you cannot flip them. Okay, if you are flipping it, then that will be a different arrangement. But here, if you flip it also, again the bracelet will be same. Okay, it is not going to affect the like appearance or whatever you want to say. It will not affect it. So here clockwise and anti-clockwise does not matter. Okay. But most of the
Okay, ma'am.
scenarios, you will see that these two are actually different. Okay, in some of the context, you can see that both are same. Okay.
In circular, if question says we have to fix 2 positions, so we have to just total number of element and minus the fixed 2 positions.
You have to fix the position of one element only. Okay. Suppose the question is, if you have 6 number of people, okay, that you want to arrange according to a circular table. Okay, around a circular table. So in how many ways you can do? So that will be 6 minus 1 factorial, which is 5 factorial.
Okay, ma'am. Ma'am,
Okay.
that formula that n minus 1 factorial. So initially, like while you like started explaining this, so there we have seen that so initial thing. Yes, ma'am. Yes, ma'am. So here for for one arrangement, there are 3 duplicate arrangements, right?
Yes.
Means we can think it in a way that these four items we can arrange in 4 factorial ways, and just so we are repeating, like there are 3 such duplicates. That's why those those arrangements should be reduced. Then we can say that 4 factorial divided by 4. So in a similar way, we can derive this formula
Yes,
as
yes.
n factorial divided by n. So
Yeah,
that's
yeah,
why
correct.
we are getting minus. Okay,
Yes, yes, yeah, correct.
okay, okay, ma'am. And ma'am, if 5 objects are given and we are doing 4 objects in a circular way, then how can we do that?
Okay, so you have 5 objects and you want to
Yes,
arrange
ma'am.
only 4
Yes, A, B, C,
in
D,
this
E,
way.
let's say.
Okay, you have A, B, C, D, and E, and then you want to arrange only 4 again.
Yes, ma'am.
Okay, so then in that case, you will have to select the items first. Okay, so out of 5,
Okay.
you have to select 4. Okay, and then you have to
Oh,
arrange
select
them in the,
means combination. Okay, okay, okay.
yeah, if you are doing only selection, okay, because you are saying that you have 5 letters and you want to arrange them in a, you have to take only 4 for circular arrangement, right?
Okay, okay. Ma'am, these things we will study in next week, or
Yes, this
this
combination will come in
combination.
next week. Yeah.
Okay, okay. Okay, ma'am. Okay.
Ma'am,
Yeah.
the question you were discussing just now, that n people are sitting in a circular table, and I mean, in that case, we will count the repetitions, right?
Sorry, in this question, right?
Yes, ma'am, the round table that you said, that n number of people are sitting around a table, and how many ways we can make those people sit in the table. So it should be n minus 1 factorial by 2, right?
See, it will not be n minus 1 factorial by 2. It will be n minus 1 factorial because their clockwise and anti-clockwise are different.
And ma'am, okay, ma'am, and ma'am, those some questions are also there that, say for example, there are B1, B2, B3 boys, 3 boys, and G1, G2, G3, 3 girls. And there is the question that make the arrangement in such a way such that B1 is not adjacent to G1, and B2 is not adjacent to G2, and B3 is not adjacent to G3. So in that case, what should we do?
Okay, so in that case, in those kind of question, you have to make again, you have to make cases and think of how can we do that. Okay, so okay, I will take a simple question first. Suppose you have 6 number of people or items, whatever you want to say. Okay, okay, let's suppose 6 persons are there. Okay, out of which suppose 3% are there. Okay, let's take 2 only. Suppose 2 people are there who want to sit together. Okay.
Yes. Yes.
Who want to sit together, which means suppose I write like this: P1, P2, P3, P4, P5, and P6. Suppose these 2 persons want to always sit together. Okay. So what we do, we consider these 2 as one person. We consider them as single one. Okay.
Okay.
So now what we do, we have P1, P2, P3, P4, and this P star. Okay. So now in total we have 5 number of people which we want to arrange them in a circular fashion. Okay. That we can do in 5 minus 1, which is 4 factorial ways. Okay. Now there is, okay, this is 4 factorial. Okay. Now the question is, answer is incomplete. So we have 2 people, okay, which want to who want to sit together. So these 2 person can be arranged in 2 factorial ways. So you have to multiply with 2 factorial. Okay. So now when you take they both does not want to sit together, then we subtract from the, we do it in a reverse manner.
Okay, ma'am. The converse method, right?
Yeah, you have to take converse, like from the total, which will be 6 minus 1, which is 5 factorial, and minus this case. Okay, so we solve these kind of question like this.
Okay. Clear, ma'am. Thank you.
Okay. Yeah.
Ma'am, I
Yeah,
have doubt
so
in activity 5.3, first question.
okay, so we are not left with, we have only few minutes. So I will take the summary of
Ma'am,
the entire session and we will solve the activity questions in tomorrow's
ma'am,
session.
this circular reverse was not understood when we are reversing.
Reversing, see, reversing, which means I said that if you want that two people should not sit together at all. Okay, so how can you do? So first of all, in how many ways you can arrange six people in a circular fashion? So that is 6 factorial, 5 factorial, 6 minus 1 factorial, which is 5 factorial. Okay, and then you will subtract the case when the two persons should always sit together. So that will be 4 factorial into 2 factorial. So this will be the answer. Okay, that's what I'm saying.
These two persons will not sit together.
Yes. Okay. So if you want these two person always sit together, then 4 factorial into 2 factorial will be the answer. If you want that these two persons should never sit together, then what you have to do? You have to do it in a reverse manner. First, you calculate when they both are always sitting together. Then you subtract from the total number of possibilities of arranging 6 people around a circular table. Like you are taking like complement function of it, complementary event. Okay, as we used to do in
If people
probability.
are sitting, if we want 3 people, तो sit ही नहीं कर सकते ना, एक साथ ही कर सकते हैं.
Sorry, 3 people.
If 3 people cannot sit together, na.
Yeah, so that also you can do. So 3 people, which means in total, if you have 6 people, okay, out of which suppose P1, P2, P3, P4. Okay, suppose these 3 want to always sit together. Okay, then how will you solve? You have 1, 2, 3. You will consider these as like single one.
Two
Suppose this is
factorial.
P star suppose. Okay, so this you can do. In total you have 4 person, like you can say 4 objects to arrange in a circular fashion. So that will be 4 minus 1 factorial. Now you have to arrange these 3 people also. That we can do in 3 factorial ways. Okay, so this will be 3 factorial into 3 factorial. Okay, so this is the case when
Okay, ma'am.
3 people should always sit together. But we want that the 3 people should never sit together. So what you have to do? You have to take the complementary event, which means you have to subtract from the total. So total will be like 6. If you have 6 people, then it will be 5 factorial ways to arrange them in a circular fashion. Right?
Okay, ma'am.
Okay, ma'am. Now
Okay,
it's
this is
clear,
how,
ma'am.
yeah, this is how you have to think about those kind of question.
Excuse me, ma'am. So, ma'am, like we are taking 3 factorial multiplied by 3 factorial, because like for 4 we are taking n minus 1. So why we are not doing n minus 1 here?
Yes, we have done n minus 1. Okay, see, these 3 we have merged into 1.
Yes, ma'am.
Right? So now in total we have 4. 1, 2, 3, and 4.
Yeah,
Okay.
that is clear, ma'am. Next one, the 3 factorial, which we are multiplying with this.
5 factorial कैसा हुआ, ma'am?
Okay, let me explain again.
Just
See.
1 minute.
Yeah.
First, yeah.
Yeah. So we have, okay, this is the thing that we have merged these 3 into 1. Okay. So now we have 4 person, like 4 in total, 4 items.
Yes, ma'am.
Okay, consider these 3 as 1.
Yeah.
So that will be 4 minus 1 into 4 minus 1 factorial.
Yes, ma'am.
Circular arrangement.
Yes,
okay. But we have to arrange these 3 also.
Yes,
These 3 are always sitting together. Maybe they are sitting like P4, 5,
Okay,
6.
so we don't
maybe
consider
5, 4,
that
6.
as circular, but it is a linear.
Yeah, that will be arranged in linear fashion.
Okay.
Okay, so that will be 4 minus 1 factorial into 3 factorial.
Okay. Thank you.
Okay, and this 5 factorial is like you have 6 number of people that can be arranged in 6 minus 1 factorial base, which is 5 factorial.
Yes.
Okay, So from the total, you can subtract this event and you will get the complementary event of it.
Okay. Yeah.
Okay.
Thank you, ma'am.
Okay, activity
Ma'am, this
questions
is
and
for
practice assignment question we will solve in doubt session. Okay, so doubt session will happen tomorrow at the same time.
मैम बट 6 minus 1 फैक्टोरियल कैसे होगा मैम? 3 का अरेंजमेंट है ना, तो मैम कैसे होगा ये?
What?
मैम 5 फैक्टोरियल कैसे आएगा?
This 5 factorial, right?
Yes मैम.
Yeah, so 5 factorial, so if you have 6 people in total, you want to arrange them in circular fashion, how will you do that?
Maximum arrangement.
5
With 6
factorial
people,
ways.
the
That will
maximum
be 5
arrangement you can have
factorial,
is 5 factorial.
right? So total, like if you have 6 people, so that you can arrange in 5 factorial ways if there is no condition that these two persons should always be together or never be together. So total we have 5 factorial ways. Okay. From the total you have to subtract the condition that they should always sit together. Okay. So total minus always together. Okay. So that is equal to that they are never together. Okay. So actually it is a complementary of it. Now is that clear?
Okay, ma'am.
Okay. So
Yes,
from the
ma'am.
total
Ma'am,
you
this
have
is
to,
for a
yeah.
particular pair, right? I mean, so this sit together thing, this is for a particular pair of thing, right? So let's say P4, P5, they will sit together.
Yeah, you can take any of the pair. Okay. Suppose you
Okay,
can
okay.
take, suppose you can take these three. So in that case, we will consider like we will merge these three. Then it will be P1, P2, and P6, and these three are merged. Okay. So those three or those 2% can be any one of them.
Okay, okay.
Okay.
Okay, ma'am.
Yeah. So you all try solving the question. So you will solve different kind of question, then it will be clear. Okay. So try solving all the questions and then we will discuss the activity questions tomorrow. Okay. Now I will just summarize all these things, what we have seen in today's session. So we have studied about the permutation. In permutation, we have seen two cases. Okay. So one of the case was when objects are distinct. Okay. And the second case was when objects are not distinct. Okay. So we had an object. So n objects are not distinct. Okay. So majorly we had these two kind of scenarios, right? Under that, again, we had two kind of scenarios. Okay. So in the first one, when objects are distinct, okay. So the thing was that repetition is allowed and repetition is not allowed. Okay. So when repetition is allowed and you have n distinct objects, so what was the formula?
N to the power R.
Yes, it will be n to the power r. Okay. So you have n objects. Okay. You have to select r out of them and you can arrange and you can repeat them also. So the formula is n to the power r. Suppose you have n distinct objects, but the repetition is not allowed. Then we have to use the usual permutation formula, which is NPR. Okay. So in this particular formula, all the items are distinct and no item is getting repeated. Okay. So in this kind of situation, we use this formula. Okay. Now see the second case when the objects were not distinct. So when the objects were not distinct, how did we arrange that? It was n factorial in total. Then we have to divide by the P1
R1
factorial.
factorial.
P1.
Yes, sir.
Yeah, whatever you can take up to pk factorial, like this. Okay, so these three cases we have seen in the linear permutation. Then we discussed about the circular permutation. So in circular permutation, there were only two things, that clockwise and anti-clockwise are different, and clockwise and anti-clockwise are not different. Okay, so when clockwise and anti-clockwise are different, then the formula is n minus 1 factorial. And when clockwise and anti-clockwise are same, okay, in that case, the formula will be half of it, which is n minus 1 factorial divided by 2. Okay, so these are all formulas that we have discussed in today's session in week 6. Okay, remaining combination formula you will see in the next week. Okay, is this clear to everyone?
Yes, ma'am.
Yes, ma'am. It is clear.
Okay, then try solving the questions and we will discuss in tomorrow's session. Okay.
Okay, ma'am.
Thank you, ma'am.
Yeah,
Okay,
thank you,
thank you,
everyone.
ma'am, for the
Thank
session.
Thank you,
ma'am.
ma'am.